Hello, my name is Colm Mulcahy from Spelman College in Atlanta, Georgia. I'd like to show you some surprises with a deck of cards, and we'll start with an old classic from the late 1950s invented by Gilberth, an applied mathematician who's still alive and well with us today. So we start off with a deck of cards. It doesn't have to be a full deck. It would help if you have an even number of cards. They're mixed up here, and what I'm going to do now is mix them up a little further. In fact, I'm going to split them into two piles and shuffle them together. Now the traditional way to do that would be a riffle shuffle, which is something like this. No great regularity, very clumsy, and then I would push those packets together. If you can't do a riffle shuffle, what we can do with the packets instead is do what are called rosette shuffles. So we do a rosette with each of the little packets and then mush those two packets together and square up the cards. And let's take a look. So they're clearly mixed up now. I didn't know where I split, no control over how they're mushed together. In fact, if you look through, you'll see that they're very much jumbled up. What I'm going to do now is put the cards behind my back and magically produce two cards, always one red and one black, from this shuffled deck. So I'll put the packet behind my back and let's see if I can produce one red and one black card. How did I do? Not too bad. Let's try it again. Amazing. Let's try it a third time. Now admittedly I've had practice doing this, but I'll explain at the end and you'll be able to do it very quickly yourself. Now it just so happens that every time I pulled it off, the top card was black and the bottom card was red. That doesn't have to be the case. Let's see what happens this time. Again, it switched. But even though we got red-black or black-red, we always, as promised, got two cards of different colours. So let me explain to you how I did that trick. Now I did start off with a full packet of cards. It's important that you have an even number of cards. And I did do a genuine shuffle, equivalent to a riffle shuffle. But the packet of cards I started with was actually pre-arranged. So let me switch out this for another one here I have, which is pre-arranged to show you how I did it. So this is arranged in a way similar to the way in which the original packet was arranged. It's not that sophisticated. Even though I said, look at how mixed up the cards were, they're not mixed up at all. The colours alternate. Black at the bottom, followed by red, followed by black, followed by red, and so on all the way through. So if I have an even number of cards, I have black at the bottom and red at the top, or vice versa. I could have red at the bottom, black on top, it doesn't matter. You don't have to have 52 cards, you can do this with 20 cards, or with, in fact, let's do it with a smaller number of cards to make things a little easier. So I've taken off here about 24 cards, 22, 24 cards that alternate in colour. Now, I do actually split them into two parts, and then do rosettes with each of the parts and then mush those together. The mushing certainly mixes things up. However, ask yourself how mixed up these could really be. Now remember, the original packet of cards, whatever size it was an even number of cards with alternating colours. That means there were no two reds together and there were no two blacks together. So when we mush two of those packets together, what can you get? Can you ever get three reds together? I don't think so. Or three blacks. That's not going to happen either. So in fact, if you look through it, you'll see that sometimes you get two reds together or two blacks together. There's two blacks. I promise you the next doubling up will be two reds. There's two reds and there's two blacks at the end. Now, it's important to show your audience the cards and say, look how mixed up they are. People listen to what you're saying and believe it, but they're not really that mixed up. And in fact, the second important point is you need to separate between two cards of a like colour to say, look how mixed up they are, and then recombine the packets in the reverse order. That's a key, crucial step. Now, the packet is ready to be put behind my back. But this time I'm going to do it so you can see it. What did I really do when I put the cards behind my back? I said I was going to pick off a red card and a black card, and apparently I was able to do it very easily. Well, how easy can it be? You actually take off the top two cards every time. Or the bottom two, take your choice. I know that those are different colours. I could have taken the bottom two. In fact, let's look at the bottom because that way we can see the faces. I got a red and a black. The next time I do it, I've got another red and a black. The next time I do it, I've got a red and a black. The next time I do it, I've got a black and a red. Now think back for a second. Those cards were actually together, the two blacks. But there's no danger of them being picked off together because one of them went with the red and one of them went the other black card went with the other red. And similarly, if you check all the other pairs, you'll find There's two blacks together, but they won't come off together, they'll come off separately. This trick is guaranteed to work because of a mathematical principle. Again, to summarize, you start with cards in alternating order. And I'm going to go back to the unused part of the packet here. This is about 30 cards. These are in alternating order. You separate into two. You do rosettes or a riffle shuffle, take your choice. You mush the piles together, straighten them up. Now here's the part that's easy to forget. You then show your audience how mixed up they are. They're not really that mixed up, and you separate between two cards of like colour, in this case two reds. And then you recombine the packets in the reverse order. Now it is guaranteed to have the property that if you start with the top or the bottom, a pair at a time, they'll always be different colours. If you forget that step about fanning the cards and separating between two cards of like colour and reassembling the other way, it will not work. You might occasionally, after the riffle shuffle, look through the cards and find that they don't have any two cards together of the same colour. If that happens, just say to your audience, look, I shuffled these cards and I got an alternating deck. Isn't that magic? You get lucky occasionally. Again, that was called Magnetic Colours, and it was invented and published in 1958 by Norman Gilberth in The Linking Ring. Magnetic Colours was based on what we now call the first Gilberth principle, and hundreds of tricks, and indeed some books have been written exploring many variations on the Gilberth principle. I'd like to show you one such idea now, and then a second one which would be quite a surprise. So I have a packet of cards here, maybe about 20 cards, and this time the colours do not alternate. I'm going to shuffle them, break them into two packets, and then mix the packets together as we did before. Now with a small number of cards, it's difficult to riffle shuffle, and that's one of the reasons I taught you about the rosette shuffle earlier. The rosette shuffle is due to Leonard Green, a wonderful Swedish magician. So you form rosettes and then you push the two little packets together. Again, this is not based on colours, so I have to think more carefully when I scan the cards, because I'm looking for something here and I see it, and you will find out what it is when I explain it in a moment. So now the packet has a magic property that's unrelated to colour but related to numbers. So I could put the packet behind my back and claim I can produce a pair with a magic property. But instead, let's just speed things up and say that I can promise you that the two numbers on these cards add up to something special. Now what could they add up to? Well, you could have two even numbered cards or two odd numbered cards or one of each. And if you study the mathematics, there's a 50-50 chance that the sum is even and a 50-50 chance that the sum is odd. But actually, this time it's a 100% chance that the sum is odd. I have a 7 and an 8, and that adds up to 15. Let's try the next two. Again, forget colours. You have a 3 and an 8, that adds up to 11. Let's try the next two. A 9 and a 4, that adds up to 13. And so on. The next time we also get 13 because it's a 6 and a 7. And then we get a 5. We happen to have some alternating colours there. It's not about colours, it's about numbers. We have a sum of 9 here, as promised. That's an interesting variation. Now, how is that arranged? Well, if you think about it, to get a sum that's odd, you need one odd card and one even card. Before we had one red card and one black card. So instead of cards alternating by colour, you want cards alternating by parity, evenness versus oddness. Odd, even. Odd, even. Odd, even. Odd, even. Odd, even, and so on. So if you start with the pack that alternates odd, even, odd, even, odd, even, the colours and suits are completely irrelevant. And then you do the little rosette. Well, the cards here, I'm down to about 8 cards because I put some aside. You have to hunt through them and look for two of the same, not the same colour, but the same parity. Two evens or two odds. And this time I see none. So I claim a miracle. That's my magician's out. It's even better in some sense. I can say, amazingly, I can proceed as before and produce two cards which sum to an odd number. Or I can say, isn't it amazing that after the shuffling I got an even number, an odd number, 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 an even number, an odd number. That's a pretty good trick. That'll happen rarely, but if it happens, take advantage of it. Otherwise, proceed as before. So as you might imagine, there are many card tricks based on the Gilberth principle. And in fact, there are different versions of the Gilberth principle, but we're going to stick with the basic binary version, which I explained to you earlier. I'm now going to show you a new SurPIse of my own creation, which, well, let's do it first, and then we'll talk about how it might work. So I'm starting once again with a packet of cards, which is quite shuffled. Now the difference here this time is that some of the cards are face up and some of the cards are face down. I'm going to shuffle these a little bit, separate them into two piles. It happens that I have two face-up cards here, it doesn't matter. I form two rosettes. The rosette idea is due to a Swedish magician called Leonard Green. And then I mush these two together. And I straighten them up. And then I demonstrate to you how mixed up the cards are in the usual way. I say, look, the cards are very mixed up, aren't they? And then, now face up, face down, this time doesn't make a whole lot of difference because some of the cards are facing one direction and some are facing the other direction. Now, what's going to happen next, it's important that the cards are behind my back. So I'm going to put the cards behind my back. There's no other cards in play here, I'm not cheating. I'm going to try to produce two cards that face in opposite directions. Let's see if I succeeded. Yes. Let's see if we can do it a second time. Two cards facing opposite directions. Yes. Let's try one more time. Two cards facing opposite directions. Let's try it one more time. I'm sorry, I dropped two cards there. Let's switch two cards facing the same direction. Can I produce two cards facing the same direction? Yes. Let's go back now and try facing the opposite direction. Opposite direction. Opposite direction. Third pair opposite direction. Fourth pair opposite direction. Let's keep track of what we're doing here because that might be interesting. So before we continue, I think we had three cards facing opposite directions. Then I dropped a pair, so I guess we're not sure what the direction they faced. Then I had one pair facing the same direction. Then I had four pairs facing opposite directions. Let's see now if I can come up with one pair facing, we just had opposite, same, opposite. So we want one pair facing the same direction. Yes, happens to be two twos. Let's now try for some cards facing opposite directions. There's one pair, there's a second pair, there's a third pair, there's a fourth pair, there's a fifth pair. And I think the next one will turn out to be facing the same direction. Okay, so let's just keep track of the numbers here. This could go on for a long time. In fact, if you had an infinite deck of cards, it could go on for a very long time. But actually, what we've done here is come up with a bunch of numbers. 3 something, 1 4 1 5, the next one I promise you turns out to be 9, and so on. What we have discovered here is the digits of pi from a shuffled deck of cards. So how did I pull that off? Well, I'll give you a summary and I'll let you work out the details. Now, this trick was starting with a deck of cards which alternated, but it wasn't red-black. It wasn't odd-even, it was face up and face down. So face up, face down, face up, face down, face up, face down, face up, face down. Let's just do that until we have about 20 or 26 cards. So that's how it starts off. We'll throw in a few more pairs here. I have face up, face down alternation, starting with a face up. Now when I show you the cards at the beginning, they are in fact alternating in terms of face up, face down. I don't draw attention to that. I say they're very mixed up, and I hope you don't spot that they are actually alternating. I separate into two packets. I twirl. I push those together. Now, earlier, when we did it with red and black, this stage resulted in a situation where we couldn't have two reds together, or we couldn't have three reds together, or we couldn't have three blacks together. But we could have two of each type. Similarly here, it will be the case that you'll never find three cards in a row facing the same direction, but you'll occasionally find two. Actually, you scan the cards and you find two that are facing the same direction, in this case two face downs. You separate and recombine in the other order, and then it's ready for what? Well, I held the cards behind my back because I would conceal something, obviously. It now, instead of having the property that every pair from the top or bottom is a red and a black, or an odd and an even, in some order, it's always a face up and a face down. So to get the 3 of pi, I just produce 3 pairs off the top. And of course, they're of different orientations. Then I do something clumsy and klutzy and pretend to drop some cards just to get the decimal point, the question mark, the questionable decimal point. And then I switch to having 2 facing the same direction. And to do that, they are of course facing opposite directions, but behind my back, I flip one over. And I produce 2, and I don't know if they're face up or face down. This time, of course, they're face up. And that's 3.1. 4 is next. So I'm going to produce 4 pairs that are facing opposite directions. And that's easy enough to do. And that's 3.14. We're off to a good start. Now I want 1 pair only facing the same direction. So once again, I take 2 cards off and I flip the top one over. And I don't know if this is going to be 2 face-ups or 2 face-downs. It happens to be 2 face-ups. That's 3.141. Now I want 5, so I want 5 pairs facing the same way. I don't have enough cards here. That's why you do need to be pulling with a full deck for this. But you would produce 1, 2, 3, and if I had more cards, I could then get the 5. Then I would switch to get 9. If you have the patience and your audience has the patience, you're going to have to do 9 using 9 pairs where you always turn over the top card. And you'll occasionally get pairs, both of which are face up, and sometimes pairs, both of which are face down. It's hokey, I know. But we're getting very close to Pi Day, and I did promise you a SurPIse. I hope you enjoyed the 2 SurPIses we had today.